Can you guys see my screen?
Yes, we see SaTScan.
SaTScan, exactly. Okay, perfect. Let me see if I just think I can do this. Okay, a little bit better. I'm gonna be looking not to the camera because I'm gonna be using the other screen. Anyway, uh, thank you for being here to hear me talking about spatial statistics once again. I know they must be tired of me talking about it, but I just love it, so I'm gonna just keep talking about it. So what I wanted to talk about today is um, case control mapping. So case control is one of the most interesting study designs that we have in epidemiology because it allows us to use it for uh, rare diseases or those diseases that are not really that prevalent, or when you need some controls that are already exposed to the disease or to the disorder or anything like that. And one thing that it's very useful for us as epidemiologists is to have a spatial case control so we can study those rare diseases without the influence of those amount of zeros. Because one of the biggest problems on spatial modeling is the amount of zeros when we have not enough data for a municipality. For instance, when we're talking about COVID, of course, we're going to have a lot of data because it was a pandemic. But if you're talking about a genetic disorder or a genetic disease, it's going to be a little bit harder for us to identify those cases and to work with them on a spatial modeling, on a spatial type of analysis. So having a case control modeling, it's very useful for those diseases. So I'm going to show you how to use that on SaTScan. And for those that are not familiar, SaTScan is a scan type of spatial modeling. So we have a lot of spatial differences on how to model the influence of space into health. And we have the autocorrelation. It was probably the most used one. So usually it's just more on statistics where you do to see if it's a high value or low value of correlation with the space. You have geographic regressions that you can do. You have space-time cube. You have hotspot analysis, GEDIS or GI star. And you have what we call a spatial scan. So a scan is based on points and not defined locations. So these points will give you a possibility of scanning the area on how that space correlates with other spaces around it. It's obviously one of the assumptions for kernel density or heat maps when it's talking about spatial modeling, but it's also something useful for us when we have this type of analysis that is case control. So SaTScan uses this scan statistics, where it literally does some scanning on the space and gives you a probability based on the risks of something. So it will have the observed amount of cases, population, or the control, and it will give you an expected. So how much we expected to see, how much we're seeing. And with that, we can model a risk ratio. So as an example, I'm gonna use a COVID one in my home state, Paraná, back in Brazil. So this one is the work that I did back in 2022, I guess. It was never published, it was never moved forward for some reason. But one thing that we wanted to test is to see if there's any clustering on how the hospitalized COVID cases were treated in the Paraná state. So we wanted to see any difference between the ICU and the wards. Because, for instance, it's different, the severity of the case, if someone is in the ward, if someone is in the ICU. So we wanted to model that relationship using a case control approach. So this is the StatsScan. It's not that pretty, as some of you may be familiar with ArcGIS, which is really, really pretty. This one is just a window inside a bigger window. But the point here is it allows you to do a lot of different types of analysis, especially spatial and spatial time analysis. So the first thing you need to know is if you're going to do a spatial or a spatial time kind of analysis. Because when you're doing your data set, you're going to need some different columns that will allow you to do this modeling. So here, when you just, I'm going to close this and I'm going to open a clean one so we can start from scratch. It will give you 3 tabs: input, analysis, and output. And it also gives you an advanced type of features for each one of them. So let's start with the input. For the case file, whenever you're gonna use case control or just a standard mapping for population, not just controlling with control files, you're gonna need a case file. For case control, we're gonna call this a Bernoulli model. So for those that are not familiar, Bernoulli is the name of a binomial distribution that is actually very similar to the binomial distribution. There have some differences, especially on the relationship with the continuous variables, but in this case, we're going to call it a Bernoulli model. If we're going to use a population file, meaning that we're going to use the amount of cases for the population, not for a control, we're going to be using a Poisson model. So Poisson is a type of discrete distribution that is for counting, just like counting as population. You're also going to need coordinate files. So as I said, you're not going to use defined locations, you're not going to use municipalities. You're going to use coordinates because you're going to use points. That means you cannot use defined locations, you cannot use municipalities. No, it means that you need to transform that into coordinates. So the first thing is we're gonna need to put the case. And for that, I'm gonna go with my so I have here a file, show you this file that have the municipality code, the name of the municipality, the state variation, the area and kilometer square. Here I have the code again, but with only 6 digits. I have the amount of ICU cases, I have the ward, and I have the population. I also have the Y coordinate and the X coordinate. And this one is for the centroid of the municipality. So when we're looking at a map, we know that a municipality is a whole area. So it's defined like location is a polygon. But again, we cannot use polygons in this kind of analysis. So what we do is that we calculate the centroid, so the center point of the polygon. And using that centroid, that point, we get the coordinate. So the Y coordinate and the X coordination. So with this file, I'm going to be able to do the SaTScan analysis. So I selected it, and it needs to be a CSV or some type of text separate values. So white space, you can have quotes, double quotes, you can have commas. And the expected things that we need to have is the location ID and the number of cases. And if you're going to use a spatial time approach, you're also going to need a date time. One thing that is interesting about this analysis is that you can control for covariates. So if I want to control that for sex, for age, for race, ethnicity, I can do it. I just need to know the covariates. In this case, I'm not controlling for it. I'm just using the number of cases. So the next thing I need to do is I need to import this file. So here I have first row as column names, and the field separator is comma. When I click next, it will give me a preview. So I need to check if it is as it was need to be. So it's the same thing as I have on my CSV file. So now it's putting as a discrete Poisson model, but I'm going to use a Bernoulli model. I can also change for a space-time permutation model, multinomial model, ordinal model. I have multiple ways to do this. This one, I'm going to use a Bernoulli model. For Bernoulli model, I only need 3 types of variables. The location ID, which is my code, the number of cases, that it's my ICU, and then I have the date time that is optional. So I don't have a date time, I'm not going to put it. It can also give you an event ID, latitude, longitude if I want, but I'm not going to do it. This one you can just skip because it's only when you have further knowledge on how to list those columns, how to label it, how to use events that are useful for this type of analysis, which is not our case. So it will give you this kind of name and this kind of file that is cases.cas. So this one is a specific type of file, especially for SaTScan cases file. If you change it, it might not work. Why it does that? I don't know. It is. So I'm going to change this very quickly because I want to change where to save it. And then I'm going to rename it again. I need to put cases.cas. Then I import it. Then I can put my control file. That is the same file, The only thing now is that I'm gonna use the words. Again, I'm not putting daytime. And now I have a file that is controls.ctl. So it's for controls. I'm gonna import it again. It's useful to change here the date. I think it is. Even though you're not going to use anything with time, not trends or anything like that, it's easy for you to use the study period. I can skip the Poisson model here, so I'm not going to put a population file, and I go straight for coordinate files. And I'm going to use a Cartesian one. Again, I'm going to use the same data set. I need to put my code ID, and then I'm going to put X coord and Y coord. And this one is going to be coordinates.geo because it's a geographic one. So this resumes the input section where you're just going to put the information that you're going to use. The important part is here. So we have different type of analysis here. We have purely spatial, we have purely temporal, space-time, seasonal, spatial variation in temporal trends, and we can also do prospective analysis. We can do purely temporal and space-time. So we can predict the behavior of a disease on a certain amount of time. So if I have, this was useful in the pandemic, and I think that there was a state or a city in Brazil that is using SaTScan to predict the behavior of the COVID-19 spread. Because since it's a point-based, you can plot the points of where the disease was located. So I have a case in this house, and then one in this house, and then one in this house. And then I can predict how it's going to spread. So it's useful for infectious disease because it allows you to predict how it's going to be behaving. In this case, I don't have a time variable, so I can only do purely spatial. And I'm going to use Bernoulli, and I can choose high rates, low rates, or high or low rates. Depending on what you're modeling, you can choose either high rates or low rates. I usually go for high or low rates because I do need to know where I don't have it, because it might be related, depending on the disease, on how they're treating the disease there, if they have a higher equipment setting, if they have more resources, if they have more information about that disease, or what they're doing there. If they have, for an infectious disease like measles, they have a higher vaccination rate there. So I can model in further to see the correlation with sociodemographic and health-related variables. Here you can also put some type of window shape. If I have a circular, if I want an elliptic one, if I want to specify the percent of population at risk. Usually I don't change this because kind of can be tricky to know how to do that. So if you're using purely spatial, I suggest you not to change anything. If you're using a space-time, to be careful when changing those defaults. So you have also a temporal wind where you can change it, cluster restrictions. So you can say that a minimum number of cases is 2. I need to have at least 2 to be considered a cluster, because only one case is not going to be a cluster. I also have some miscellaneous, so Olivera's F. I have a drill down that I can put some information here as well. Power evaluation. So SaTScan uses Monte Carlo applications. Inference that I can adjust if I want sequential Monte Carlo to be some cutoff, if I want Dumbo approximation, just some weird things that we want to change here. Sometimes it's useful, like I said, with Natalie, to increase the amount of applications. But depending on the amount of municipalities you're testing, on the amount of points you're testing, it's going to be very time consuming. So sometimes it's not useful to change it. The standard is 999. We can also have spatial and time adjustments, but for now, we're going to stick with these ones. Then that, we can just choose the output. And then I'm going to create here report case control COVID-19. Then I can put some information on what I want there. So I want cluster information, stratified cluster information, location information. I want risk estimations and simulated log likelihood ratios. Sometimes it gives you an option to have your shape file. Sometimes it doesn't. And sometimes I use the HIML file for Cartesian map. Here in the output, it's also important to check if you want a Gini optimized cluster collection. So for those that are not familiar with spatial analysis, Gini is a type of correction that you do that allows you to use only those that are really significant. Because sometimes you're gonna use a Gini optimized one without the Gini optimized one, and it's gonna give you some location that is a cluster, but the significance is not really correct. Also, it's important if you want to have geographical overlaps or not. So if one city can be part of multiple clusters, this one only accounts for the same type of clusters. So it can be depending on a time kind of modeling to have this overlapping with low and high clusters. But for only spatial modeling, it won't give you geographic overlap. So you won't have the same municipality being part of 2 different clusters. If I have temporal output, I can choose some other things. I can choose to report Monte Carlo rank or choose my own p-value. And also some alerts that I can change, can I send for emails, because again, it's time consuming. So now what I need to do is just click here. And it gave me a report. This one was really fast because it's only 399 municipalities. But one thing is that it created a report for me saying that the study period was this one. I have 399 locations. I have these populations. I have this number of cases. And I have these % cases in the area. and it gives me the clusters detected here.
Natan,
So,
can you maximize the window so just so it's easier to look at the report?
yeah,
Yes, thank you.
I try to increase, like to zoom in, but this software is a little bit.
No, this is good. We can zoom in with Zoom as well. It's
Okay,
fine.
perfect. So it gives you the codes of the first cluster, and then if it overlaps with other clusters, which it does, if it's a Gini cluster, which is not, the coordinates and the radius, the population there, the number of cases, the expected number of cases. So I have 11,000, and I expected it to be 14,000. So I do have a relative risk of 0.05. And then the p-value gives me that is a very significant cluster. And it's going to do the same for every single one. And it also gives you the outputs, the analysis, the settings, what it did, what it doesn't, what it didn't do. And it also created this file. So for those that are a little bit more familiar with the shape of the Paraná state, can recognize the points here forming the shape.
Oh, the points. Okay.
The points are the municipalities.
Well, let's show a map of Paraná, maybe in Google, so people can see.
Yeah.
Oh, yeah, that's good. That's good already. That's already fine. Yeah.
Yeah. So if you can see here, this shape kind of resembles something that is similar to this. Let me use this one.
Mm-hmm.
So you can see how it kind of resembles.
Uh-huh. Nice. And
Right?
just so people know, those regions in the right, they are not the municipalities, they are sub-regions. So that's why you
Yes.
have more points in the left than in the right.
Yes, these are subregions. They're not the municipalities. The municipalities are those that are here. Also, this part of the state, which is this part, is where you have most of agriculture land. So it's a land where the municipalities are bigger. And this part of north and closer to the border with Paraguay, Argentina, and the state of Santa Catarina, then it gives you more industrialized and smaller municipalities. So here you can see that you have high clusters where it occurs more, and here you have lower clusters where it occur less. So let's not forget that we're modeling a case control. So the high clusters here indicate where it's more prevalent, if you can say that, the use of ICU, where in these points in blue is where you're gonna have more of a wards type of treatment for those that are hospitalized. So it gives you some questions on how and why those spaces are being overflowed with ICU cases. We can change this to a map that is going to be easier because these points are not very good to looking at. I already have a map here where you can see the clusters. So I only have the high clusters here. I do not have.
One minute, Nathan, please. I was
Yes.
trying to see whether AI could recognize my hand or something like that. So what do the points represent in the map we're initially looking at?
the points represent the municipalities.
Okay.
So are the middle points of each municipality here.
Okay.
So this is the state, and each point represents the middle part, like the exact middle part of each city.
Hmm.
As you can see here, this part of the state, you have smaller municipalities, and this one you have larger municipalities.
Okay.
And in the points, let me see. You have more points here than here, because here is where you have these larger municipalities, larger cities.
Okay. Yeah, because at some point you guys mentioned that the points at the right were more of sub-regions, so I couldn't relate.
Yeah, the other map that Natan showed was not this one with all
Yeah,
of the
this
municipalities.
one.
Yeah, that one is the sub-regions of the state, which are
Okay.
just a bunch of municipalities on
It's
the.
just like the counties, yeah.
Okay.
Yeah.
Cool.
So here I have the clusters that was formatted with the it's the same clusters. The only thing here is I'm only showing the high clusters. So here I have the clusters being separated by the risk ratio. So those with higher shades of red represent higher rates of ICU for COVID-19 treatment. So this region showed a lot of ICU cases. This one as well, of course, more than what was expected. This can be seen, of course, as why we do have this amount of municipalities using more ICU than ward. Probably because the cases were not because they were more severe, but because the structure here was not adequate. They have less beds. So the cases increased the severity because they couldn't be treated beforehand. That's just an assumption. I'm not saying that it's what it is. But it gives you a case control. So it allows you to see and to model this relationship between a case and a control, and it gives you the risk ratio.
So
for
the
this
the
disease.
case is ICU and the
Yes,
control is ward.
ward, yeah.
Okay, so both of them, they had COVID. That both of the groups were COVID positive and how they were treated. Okay, and then this spatial analysis would basically compare what would be expected based on the population and the close by municipalities. Is that so?
Yeah, the population meaning the control cases.
Okay.
So let's take back to here. Just like this city, Arapongas, which is close from where I come from. We have way more ICU than ward.
Okay.
And when I say way more, it's not because it's just 20, 26. So you can see, oh, it's not that much. But for ICU cases, where you have over 700 cases in ICU in that period of time, and you have more ICU cases than ward, something happened there.
Okay.
The same thing goes for other municipalities. So sometimes we do have, just like this one, 15 and 13, or 40 and 35. Of course, that we have some municipalities that will have like this one,
Yeah.
1,700 and then 3,700.
Would be more expected.
More expected because we expect that people will not have that severity. So, but some municipalities, they do have more ICU cases than ward. And this type of modeling can indicate me where it occurs, so I can try to understand what's behind that. It's because it's related to infrastructure. It's because it's related to providers. It's because of the type of virus. So if it's COVID-19, there are some 2021 cases here almost the whole year. So we already have Delta, we already have, which the other one was Omega? There was already in
Yeah, it was
2021.
Omega, it was Gamma.
So was this type of virus or it's something different? It's because we need to control that by age because these areas have more older people.
And then the distinction here between a regular cluster analysis is that you're able to do this case control design.
Yeah.
And then get this notion of, okay, comparing to what was expected, where we have the worst or the best outcomes.
Exactly.
In this case, you're showing the high clusters, right? The hot clusters.
Because you cannot when you're doing a case control type of analysis, usually what you do is that you can divide the cases to the controls because sometimes they pair it. Like you're just trying to identify the differences between the case and the controls to see how different the disease are based on if they are similar or if they're not. But in this type of analysis, if you just divide the amount of ICU cases and the amount of ward cases, it won't represent anything. So this type of analysis models it. So it models the cases and the controls. It not just divide and does not give some prevalence. It gives you what is expected.
And it's still using the spatial component to that as well.
Exactly.
Not only, okay, nice.
And then with that, since we can have the risk ratio for each municipality, and what we can do is instead of using the prevalence to do some regressions to understand if it's related to the amount of hospitals or the providers or anything like that, or the age of the population, you can use the results. You can use the risk ratios to do that. So we're going to model the risk ratios and to identify if the higher the risk ratio is related to a higher prevalence of older population. So that is something very useful where you can have the risk ratio being used as your outcome, not just the prevalence, because sometimes the prevalence will be high in cities like Maringá, where I'm coming from, or Londrina, or Curitiba, which are the biggest states, the biggest cities in the state that have the biggest population. The prevalence will probably be higher because it's where you have more people. So for infectious disease, of course, like COVID-19 is where these occur most. But with this type of analysis, we can identify more than that. So we can use this for infectious disease. We can use this for accidents, car accidents. We can use this for snake bites, scorpion stings. Especially if you're going to model cases where you have severe cases, but you're going to compare adults and older adults, the elderly. Is a case control type of analysis that you can do that. So I just wanted to show you how to do that type of analysis. Of course, there's a lot of more things that you can do with it, but that's what I had planned for today, just to show you how we can model this type of diseases, especially infectious diseases, to create this case control type of analysis.
Awesome. I was also curious when you were showing the settings for running the model, like you have a bunch of different distributions, etc. But you could specify the population, the proportion of population at risk for the condition, and for this one you set at 50%.
Yes, 50%.
Which is the standard. I was very curious with seeing if we could do something like for COVID, that we both with the infection, of course, the population, pretty much everyone was infected with COVID. But then after with vaccination as well, if we could, do this some sort of even month by month. Like in this case, you didn't do a time analysis as well. You did a group, right, for a year, for a few years.
Yeah.
But doing this, looking at like the advancement of the progression of the immunization, and even of the actual infection as well, like how many people are being, how many tests come out positive from all the tests that you're performing,
Yeah.
and all of those rates we were looking at a time.
One thing that's interesting is that it allows you to have predictions that is based on small things as day. So you can have years, months, and days. So you have, if I want to predict, I can account for each day I have a new case. Okay, I'm gonna use days. I won't use years. I can use as many days as I want. Of course, that it will increase the time that you're gonna give your computer to run the analysis, but you can do some permutations in that as well. And it will give you, like you can model it like, okay, in this inflection, I want the prevalence to be 50%. In this inflection, I want this to be 30%. In this inflection, I want to be 10%. Because the prevalence dropped. You can do that.
Can you open the settings so we can take a look at those as well, just for the sake of curiosity? I guess you would run it again. Yeah. Percent of population at risk. And then percent of population defined in the max circle size file.
Yeah. So I can have a file that will give you, how can I say this? You can give them the prevalence of the population at risk for each place that you want them to be the maximum elliptic or the circle that is going to be expanded.
Do you think that this percent of population at risk, is it of having the case, like for instance, like going to ICU, or actually being infected at all?
In this case, since I'm not modeling the disease, I'm modeling the going to ICU, then it's going to ICU.
Okay.
So that's going to be the people that are infected with COVID-19. But you cannot put a number greater than 50%.
Okay, because I was thinking about like something else, like for car accidents or even like snake bites.
Yeah.
People are more at risk if they live in places where the snakes are, right? Maybe more in the rural areas, more agricultural areas, or even, of course, with the changes that we are seeing, the snakes come more into the human environment as well. But then this would be since we are not modeling the actual the thing happening or not, COVID happening or not, but actually if it happens, what is the risk of you having the outcome, which is going to the ICU?
Yes.
And in this case, it's 50%, but it could be based on something like some prior knowledge that overall, from all the cases, 10%, I don't know, 30% of the people had a severe case and then needed ICU or something.
Yeah. In this case, I chose 50% because we're talking about just hospitalized cases. And when you go to the hospital to treat COVID-19, it's
already bad.
Closer to 50%. it was not bigger because we didn't have the beds. The health system was not ready. So some cases that were supposed to go to ICU stayed in the ward because we didn't have the ventilators.
Okay.
Or we didn't have the providers. So they stayed in the ward, but they should be in the ICU. So I put it 50% because we cannot be sure how much, but it was close to 50%. But if you have like a disease that is really rare, like a genetic disease, you can lower this to 5% if you want. That is fine.
Okay, so just to be sure I'm following Nathan, so kind of the base population would be the number of people who visit the hospital
There's
and
one
not
population at
the
risk.
population of the municipality.
Yeah, for his analysis, yes, Sabali. It's
Okay.
the hospital, stratified by ICU or ward.
Okay.
Yeah. So you can do that for the spatial cluster. So you can have like smaller or bigger clusters, because sometimes it's going to give you like a huge cluster of 50, 100 municipalities, 100 cities.
Mm.
And sometimes you don't want that because you know it's not true.
Yeah, it's not really helpful as well, right?
So you can like lower it, putting how many people are in risk and giving the exact size of how much the population at risk will move, for example. And you can also do that for temporal. So you can do maximum temporal clusters because it will give you like a time, like a time period. So from July to September, it was a cluster. Then it wasn't. So it gives you exact time on when it happened. And then you have, of course, other things that you can change here. But I just wanted to show you the potential of this Romulus time cap. So I'm gonna stop talking. Anyone else has any questions, suggestions?
I had a question on the procedure. So you
Yeah.
have the output from SatNav and then you went to QGIS. So what do you use from the output from SatNav to bring onto QGIS to create the other map?
Great question. It was this thing here. Let me show you. Oops. Real quickly.
Thank you.
So it gave me these things here. So I have the columns, the GIS, the log likelihood, the risk ratio, and you have the DBF.
Okay.
So I can go to Excel and open it. Where is it again? Analysis, and then all the archives. It gives you this. So I have the location ID, the observed, the expected, the observed divided by expected, and then the relative risk.
Oh, okay. And then you bring that onto.
And then I have the location ID, and then I bring that to QGIS. So here I separated by clusters, and then I created one just for clusters, and then I did this. As you can see, you have here the cluster risk ratio, and the local risk radio.
Okay. And then you use the location ID to merge into the coordinates for the
Exactly.
agent. Okay, perfect. Thank
So
you.
it was, I was able to do that.
Great. Thank you.
Yeah.